All right, in the spirit of project-based learning, I really hope that if you're watching this video, you've already tried to solve this problem on your own. It's really the best way to learn. Go in there, get your hands dirty, break the thing, right? Maybe if you did this right, you even got frustrated, and maybe you got stuck. And if you did, that's great. We're doing something right, all right? But I don't want to leave you stuck forever. And if you did come up with solutions, I'd like to do this service of providing two potential pathways for solving this problem right now. I'm going to share with you one potential solution. We're going to make this thing work right now. And then the result I'm about to share with you is still not going to be ideal for reasons you're going to see. So then I'm going to show you one more way to think about this and leave you with yet another challenge that you can go off and play with on your own. Okay, so let's just think through one more time what's happening here. And I just changed those numbers back to 15 again. Let's send this to the simulator. There we go. Deposit 15. Deposit 15. If the two players agree on the outcome, we are fine. But if the two players disagree on the outcome, player 1 says 1, player 2 says 2, the funds are stuck. Well, there's a few different ways we could think about solving this problem. But let's take a really simple approach. If the players disagree, what if we simply return their money to them? All right, you guys can't agree. You each get your 15 ADA back. Let's implement that. So when do I have to look for that? Where is this problem happening? I checked if both players agree. If they do agree, if this is true, if their outcomes are the same, then we go ahead and we pay the winner. The problem in this contract is if they disagree, what do? We close. We don't want to do that. We don't want to close here. If these players disagree, what we need to do is refund their money. How do we do that? Well, payment is a contract. And if the players disagree, can't we just pay them again? Can't we just pay them back the money they put in? So let's see. I know I've done this once before, so I probably could cut and paste from somewhere else in my file, but I'm going to try this. Right, I remember. That's not working. I can't use a party. I have to use the payee block and then put the party inside of that. Let's say player 1. Okay. If the two parties disagree, pay player 1 how much? Well, not the full 30, but just the 15 they put in. How much of what? ADA. And from where? From account 0. And let's just copy and paste this from right here. Pay player 1 back their 15. Who else needs to get 15 back? Player 2 does. Watch this. I can just grab this pay contract and then continue by then paying back the other person right here. And after those funds are repaid to the players, then we are done. That should be okay. Now let's see what happens when we send this to the simulator. Whoops, got to reset again. I always do that. Reset, send to simulator. Now, does the basic functionality still work? Both players can deposit. Let's say player 2 won, and they agree on that. 2, 2, player 2 gets the funds. But what we just added is the ability to navigate disagreement. Player 1 says 1, Player 2 says 2. That's much better. Player 2 gets their funds back. Player 1 gets their funds back. That's an improvement. But I'm still not happy with it, I got to admit. Because now, sure, nobody's going to lose their money, but what about just a dishonest actor? One thing I could do in this contract is, I could tell the truth when it's in my benefit, but if I lose the bet, I could just report otherwise and then just get my money back. That's not ideal. So let me give you another challenge exercise, okay? That was one solution to our problem. We just added a little bit of code right here, right? If people disagree, right? If these values are not equal, these outcome choices, then we give everybody their money back. Although it works, I'm still not happy with it. So another thing that's introduced in Marlowe is this idea of third parties. In a financial contract where people have incentive maybe to not always tell the truth, we should account for that. And one way to account for that is with a third party. Now, I'm really going to leave this to you here. Check it out. In this escrow contract, this is an example of a contract in the Haskell editor tab of the Marlowe Playground that we can actually take a look at in the simulation. And without going into the code, let's just look at how this code works. Let's compile it. When it's done compiling, I can send it over to the simulator. You could also look at this as blocks in Blockly. I'm going to leave that to you if you'd like to explore that. I just want to simulate this code and see what happens. Here's some code where somebody called Alice deposits 450 units into the account. Alice makes a choice. What are my... Oh, the choice must be between 0 and 1. Okay. Let's say Alice chooses 0. Let's say Bob chooses the same thing. I don't see Bob. All right, so Bob didn't deposit anything. What happened here? Alice deposited 450. It looks like they agreed by saying 0, and therefore the ADA got paid to Bob. Okay. Let's see. Alice puts money in. What if their other choice was 1? 1. Oh, and they both choose 1. The funds go to Alice. So this is similar enough to our betting contract. It's just that only one person is putting money into the escrow account. What if they disagree? Alice says 0. Bob says 1. Then we introduce a third-party participant named Carol. And Carol... Well, I got to look at that again. What happened there? Alice says 0. Bob says 1. Carol... A moment ago, so Carol then says it's either 0 or 1. Check it out. Okay. So Carol can say 0 or Carol can say 1. If she says 0, we saw that Bob got the funds. If she says 1, cool, Alice gets the funds. So now you've got this third party making a final decision. So your last challenge for this starter kit is to go in, open up this escrow contract, look at the code either here or by sending it to Blockly, and get a feeling for how this logic works. You're going to recognize some of this, but it's not exactly the same as our betting contract. Okay, this is more of an exchange for services, and you can actually watch a video of Simon Thompson going through this code. I'll share a link to that in the materials accompanying this video here, okay? But you can review this code and you can try to implement this idea of a third party by looking through this contract, seeing how it works. There's Carol right there, okay? And then if you'd like to, try to incorporate a third party into our bad bet contract so that the winner gets paid, all right? It's not just a place where if somebody chooses to just say the wrong answer after they lose, they get their money back, but instead we have this third party saying what the results are and who should get the funds. Now, hopefully, you're also wondering, well, why should we trust Carol? And if you're wondering that, great question. One of the real cutting edge path, what's the word I'm looking for? On the real cutting edge of what's happening in the blockchain space right now is we have a lot of people looking at ways to bring real world data onto the blockchain. So as a simple example, let's say that the bet that we wrote was about some real world result that's reported in the news or through some other data feed, right? It could be sports, political, what's the weather going to be tomorrow, whatever. In cases like this, you might not even need to rely on what this or that person says a result is. You might be able to pull that data in and have that data inform who won the bet. That's beyond the scope of this starter kit, and there's a lot of work going on out in the world to come up with the best possible solutions for that. We will cover that in a future starting kit. It's going to be really fun talking about bringing real world data into blockchain transactions. But for now, I just want you to know that that work is ongoing, and we'll be excited to get to it as we continue to go on this learning journey together. All right, that's the end of this, the very first Cardano Starter Kit from Workshop Maybe. Thanks for sticking around with me. I'm really excited to keep making these, and I love nothing more than feedback. So please tell me what you would have said differently, how I could make this more helpful to someone like you. And let's go on this journey together. Please be in touch. Once again, my name is James Dunseith. I run an organization called Workshop Maybe based on the East Coast of the United States. And I am so excited to continue learning and building our network within the Cardano ecosystem. So be in touch and take care.